In this video, I will show you how to graph a piecewise function. Now, a piecewise function has different pieces. Whoa, you did not see that coming. Each piece is going to have at least one endpoint, and the domain, see how it says x is less than -3? That's the domain of this piece. It helps you find the endpoint because I know that the endpoint must start at -3. So the endpoint is going to be -3 comma something. I need to know the y value though so I can graph it. So to find the y value, I need to take the x value and substitute it in to this piece of the function. If I put -3 right here, that's -3 plus 4, that's 1. So that tells me that -3 comma 1 is the endpoint of this piece. I also know it's going to be an open circle because it's not included. It's just we want values less than this point, not equal to. There's no equal to. So open circle at -3 comma 1. So here I go. -3 comma 1 is right here, and I'll put an open circle. Now, when it's linear, I don't need a table of values. I know how to graph y equals mx plus b. I don't need the y-intercept because I have this point, but the slope is 1 over 1. So normally I would graph like this. I'd go up 1 over 1, up 1 over 1. I missed a little, but you get the idea. But wait a minute, slow down. We want x values that are less than -3. That means we need to stay to the left of -3. This function is to the left of -3. So these dots I started to put, they're to the right. So that's going the wrong way. So instead of going up 1, right 1, I need to go down 1, left 1 like this. So this piece of the function is going to go in this direction. And let's go ahead and erase these extra points. So that's it. We've graphed the first piece of the function. Now I'm going to change colors to help you keep following what I'm doing. So now I'm going to graph this piece of the function. Think of it as y equals -6. That's a horizontal line, by the way, just a horizontal line at -6. Anyway, we have two endpoints. We have the first endpoint at -3 comma something, and we have another endpoint at +3 comma something. Normally we would take these x values and plug them in. There's nothing to plug into. It's just telling me that y equals -6. So that means that the y value is automatically -6. So these are the endpoints of this piece. So -3 comma -6 is right here, closed circle because or equal to. Okay, and then +3 comma -6, open circle. Alright, so and we already discussed that it's just a horizontal line. So there you go. So that's this piece of the piecewise function. So we have one more piece to go. I will do this piece in green. Think of it as y equals 1 over x. Alright, this is not linear. 1 over x is it's a rational function. Okay, it's the one that looks like this. It's like bam, bam. It's that type of deal. Okay, so I'm going to deal with that in a minute, but that's going to be weird. Kind of looking forward to it. But let's start with the endpoint. I know I'm going to have an endpoint at 3 comma something. So 3 comma what? If I plug 3 in, then that's going to be 1/3 minus 3. So I need to work that out, with like denominators and stuff. So this would be 1/3 like denominators. Alright, so that's 9 over 3. So that's -8 thirds. Okay, I really need a decimal. So let's see, what is 8 divided by 3? That's 2.7. So 3 comma negative 2.7. This is where my endpoint is going to be for this rational piece. Okay, so 3 comma negative 2.7 would be about here. Okay, and that's going to be a closed circle. All right, I think I'm just going to do maybe a point or two. I'm gonna go ahead and do a table of values because this is a little bit more crazy. Okay, let's just get 1 or 2 points. It has to be greater than or equal to negative 3. Well, we covered the equal to part. Did I say negative 3? Greater than or equal to 3? So let's go greater than 3. So for example, what about 4? Okay, I don't want to do a bunch of these, so I think I'll just do one more point. So let's see what happens at 4. So at 4, I'm going to have 1 over 4. Alright, I'm still looking at this function right here. So that's 1 over 4 minus 3. And again, I'm going to need like denominators. This is kind of annoying. Okay, so that's going to be 1/4 minus 12/4. So that's negative 11/4. Okay, what is that? Let's see, 11 divided by 4 is 2.75. So this is going to be negative 2.75. Okay, so I've got 4 comma negative 2.75. Okay, so it's just a tiny bit lower than this one. Alright, so it's going to be like here. And actually, now that I think about it, remember I told you that little sketch of the rational function? The parent function, okay, of this is just 1 over x. The parent function looks like this. There's an asymptote at the x and y axis, and we have a branch here, and we have a branch here, approaching the x-axis. The only difference between the parent function and this is the transformation of the negative 3. That's down 3. So guess what? That means that instead of having a horizontal asymptote that is the x-axis, this horizontal asymptote is going to move down 3. So that means there should be a horizontal asymptote here at negative 3. So see how these points are really close together? Guess what? If I kept picking more values going to the right, they're just going to get closer and closer to this asymptote. They're barely going to move. So with that in mind, it makes it a little easier to see that as I go to the right here, it's got to just approach this asymptote. And so there it is. That's the third and final piece. So that's it for number 15. Let's do one more. Alright, so another piecewise function. So let's start with the top piece, y equals negative x plus 3. Alright, so I'm about to graph this piece of the function. I see that it has an endpoint because of the domain. The endpoint is going to be 4 comma something. 4 comma what? If I take this 4 and plug it in, that's going to be negative 4 plus 3. That's negative 1. So this is the endpoint. Closed circle because or equal to. It's included. Alright, 4 comma negative 1 is right here. Closed circle. This is the endpoint of this piece of the graph. Less than or equal to. That means we should be going to the left for more points. Now this is linear. That makes it really easy because I know what to do with y equals mx plus b. The slope is negative 1. That means down 1 over 1 to the right. So normally I would go like this, down 1, right 1, down 1, right 1. But wait a minute, I just told you that we're supposed to go to the left. So these points are going the wrong way. So I really need to be going this way. Up 1, left 1, up 1, left 1, like this. Okay? So this is what this piece of the graph is doing. Okay, and let me just quickly erase these extra little points over here. Okay. Now let's talk about the other piece, which is a rational function, which is weird. So y equals negative 4 over x. So let's find the end point of this piece. The end point is going to be at 4 comma something. If I take this 4 and plug it in so I can see, that's negative 4 over 4. So that's negative 1. Interesting. That's the exact spot where my other function left off. That's pretty weird. So it's going to be the same spot right here. Boom. Okay. That's okay, because actually, can I undo that? Because this is supposed to be an open circle, so the only thing I would do differently is just for visual purposes. Now understand this: if you have an open circle and a closed circle in the same spot, it's just a closed circle. So don't try to do that. Here's what I've seen a lot of students do. If you notice that there's already a closed circle there, and then you need an open circle at the same spot, I'll see students do this. Put a giant open circle around it, and then they'll do whatever is happening. Don't do that. If you put an open circle and a closed circle in the same spot, it's just a closed circle. Okay? So you don't need to do anything to make it visible. I'm just doing this so you can see, so you can follow me. But this is simply a closed circle. Nothing else is happening that's special. So anyway, this is greater than 4. So I need to have more points going to the right. Okay, but here's the thing. There's no shift. There's no vertical translation or anything like that. The only thing there is, well, okay, I mean, there's a vertical stretch by a factor of 4 because of the 4. But that's not going to affect the asymptote. So the parent function, because this is really what I'm driving at. The parent function of this is 1 over x. That's the parent function. And we know that this function has the x-axis and the y-axis are asymptotes. All right, we got the vertical and the horizontal asymptote. Okay, and the function sits like this, like boom and boom. So if I do a vertical stretch by turning this into a 4, that's not really going to affect the way the graph looks very much. Okay, I'd still basically be looking at the same thing. But this negative sign in the front, what is that going to do? That negative sign is going to have the effect, that's a reflection over the x-axis. So this branch is going to end up here, and this branch will end up down here. Okay, so instead of these, I now have these. Okay, so the x and y axis are still the asymptotes. So I'm expecting to have a branch down here approaching the x-axis. So by doing that analysis, I don't need to do a table of values. You can imagine that if I were graphing the rest of this this piece, if I were graphing this this branch of the function, it would be doing something like this. You know, it's going to go through here, and then it would approach the x-axis, and over here it would approach the y-axis. All right, it's got to approach that asymptote. It's doing this. But this is a piecewise function, so I'm not going to graph this piece of it. I'm only going to graph this piece. Okay, so I can do it now though, because it's going to start here, it's going to pass through here, and it's going to approach the x-axis as an asymptote. And that is it. Okay, that is what problem number 16 would look like. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.